All right, welcome back. We are OOP3200, and that's Object-Oriented Programming 2 at Durham College in the fall 2020 semester. And it's week 11, and we're supposed to be talking about Java classes continued, kind of. Let's go over that. So, a few things today. In class exercise 10, you should actually say week 11, I'll be okay. In class exercise 10 is due Friday. Java Quiz 1 has been released and is due Sunday. Again, with Java Quiz 1, I believe it's 25 questions. You get 35 minutes and you get 2 attempts. So from now until Sunday at midnight. So anytime between now and Sunday at midnight, you can get that done. And then we're going to be talking about inheritance today a little bit, only because I want to get a jump on it before we get into the next part. We're sitting at week 11. We're supposed to be talking about some of these topics, and we've kind of already talked about them from last week. And all I'm doing is filling in some of the spaces in here. So the things we didn't cover, we're covering. And we're supposed to be covering inheritance week 14, kind of the last week of class. I wanted to get a jump on that today because there's quite a bit of things that we can do with inheritance and polymorphism. Now we're supposed to talk about it even week 13. Look at it says week 13, week 14. But I want to, like I said, I want to start rolling with it now because you guys know about inheritance already. It's not new for you as C++ programmers. But how does that look in Java, and what can we do with it today? So that's what we're going to be really talking about. So that's where this part all is. But before we get to that, I want to talk about another topic, which is what happens when I have a starter like this, some kind of GitHub link, and I want to go from there. So there's a couple tools we can use other than the one that's built into IntelliJ, and I want to talk about that. But here is our GitHub link for ICE9 as an example. I want to download this, so I'm just going to download this code. So download the code, and let's put this inside of a zip archive. Again, as a zip archive goes, if you haven't had a chance to download 7-zip, just some tools here. So I recommend 7-zip over the built-in Windows decompression stuff that comes with Windows. I find that it's inconsistent and it's a little bit confusing sometimes. So whereas 7-zip is very straightforward. So if you haven't had a chance to download 7-zip, please do so. I think it's just easier. I don't like RAR. I think RAR can produce problems. So we've downloaded everything. Where is it? As an example, well, here it is. And I want to grab this thing and let's put it on my desktop. So we'll go to desktop and OOP3200, and we'll just paste it in there. All right, so that's what I expect you guys to just download ICE9 from last week, and we want to turn this into ICE10. So what do we do? Well, let's unzip it, and let's inspect it a little bit and see what we get inside of the folder structure. So this is the folder structure you get, right? So you get an src folder. You get the .idea folder, you get a CA, a Durham College, and some Java files, right? So main.java and vector2.java, we get those 2 files. So again, but I want to make a brand new project from this and kind of include this. How do I do that? So let's explore that. So I want to open up IntelliJ IDEA. Here we are. A lot of times it'll open up with our previous project, but we want to make a new project, but we want to do something like open or import. First, let's do a new project. So we'll call this, let's start like this. Let's try this one. So we'll start this one. We're basing it off our previous project. So we're going to say the same thing as we did before. Yes, we're going to do this. Open JDK. Next, we're going to use a command line app. Next. And I'm going to name the project again, OOP3200 F2020, and it's going to be lesson 11. All right. Now online, I'm going to call it ICE10. Okay, but let's see how this works. So I'm going to finish this off, and let's suppose I want to keep my main, but I want to in kind of include a new file in my source files inside Durham College. How do I do that? So again, there's a couple things. I can put new, right? That's a brand new file. But is there a way of importing a file from my previous, like how we have, in Visual Studio 2019, we have this like add existing files thing. Can we do that? Is there a way of dragging and dropping? And where does this stuff live anyway, right? So if you notice here in new, we can do new, but now it says file, scratch file, package, HTML file, and a bunch of other kinds of files. Data source, and this talks about different kinds of connections to databases, which are pretty cool. Driver, an HTTP request, and a diagram. All right, so notice this says Java class diagram. We're going to get there too. I want to try different things today. Swing UI designer, we can make a new UI form, and this is really cool. You can actually make UI applications like right from the get-go with this. We might explore that a little bit later, but notice that I don't see, unless you guys do, a place where I can kind of include stuff, right? So if I say show in Explorer, it brings up Durham College, and then there's main Java. So what happens if I take the stuff that we have from our previous stuff? Here's our previous library, right? So we're going to grab this vector2 Java file, and I'm going to kind of paste it in. Copy paste. Does it appear here? Yeah, look at that. Here's vector2 Java, right? And now, can I access it? That's a different story. So there's vector2 Java. You see, it's all in the good. So that's a way of doing it, right? I mean, as long as I copy paste, IntelliJ IDEA is smart enough to pick it up, which is good. That's what we want to do. And what about if I override something? Will it clean up this one? Like, what if I take main.java here from exercise 10. So here it is. This is the previous exercise, ICE9 master. Take main.java. And you know what? I want to override the other one. Is it going to clash? What is it going to do? So Control V. It's going to say replace this file at the destination. Allows me to do it. And if I click this back again into main.java, then we're good. It's that simple. It's not like that difficult for us to kind of move files around. Let me just close some of this off now. All right, so that's the first step. So first thing is we can always do that. We can always make a structure, and then using our file explorer do it. We also have our run configurations already set up. Up here we have a configuration. So let's take a look at the configuration up here. So if I go to edit configurations here, you can see that I have an application main. Here's the main class, ca.durhamcollege.main. Notice that is the run configuration. Here's the working directory. Here's the use class path module. You have to have all that in there. This is how you configure it for the first time. You can take a look at code coverage. It looks like IntelliJ IDEA and logs. So there's nothing really here that tells you that there's anything that's going on. Templates, we can choose different templates from here, from our run configuration. And it says before launch, we want to build. Okay, so that's pretty standard stuff. I don't think there's anything here that's too crazy in terms of how we run it. There's also this build project as opposed to run project. So run main, there's also debug. We've talked about debugging in the past with this stuff as well. So let's just run it and see what we get. Does it work? Because again, we've just started off a brand new file and we want to check to see if everything works. And we got the first point. So 3, 4, and we're going to go to 10, 20. We've seen this before. And then there you go. You've got your distances and all that kind of stuff. So that should have been helpful for you in terms of importing. So you can always do that. You can always make a new project and do that stuff. I think that's kind of a good thing if you want to start one project from another, and you want to kind of create your own structure for the name and everything else. Okay, what we haven't done is we haven't put this up on GitHub. I'm going to do that now for ICE 10. So again, for GitHub, I need to go to VCS, and enable version control. But let's suppose, before we get there, instead of using version control that's built into IntelliJ, you want to use an external tool. Maybe you're a person who needs to see stuff. You're a person who needs to be visual. So there's some great tools out there that can help you with that. One of them that I like is Gitkraken. Gitkraken is a pretty cool tool. It's free to download. There's also, I'm going to recommend a few. There's also Sourcetree. So Sourcetree is very popular. Notice that both tools have a visual representation of your commits and your branches, which is pretty cool. And the other one that is common but less maybe nice is desktop GitHub. GitHub desktop is very bland. It's a no-frills kind of user interface that can avoid you doing any kind of work on the command line. There's also, of course, command line, and if you want to install Git on the command line, you use git-scm.com, and then you'd install Git on the command line. If you're someone who's a command line person like me, I do Git on the command line mostly. Okay, so let's use Gitkraken. So please, I'd ask you to download Gitkraken. I'm going to put this link on in our files today. So I'm going to go into week 11 where it says in class exercise in here, and let us add a new link, and I'll say download Gitkraken. Now there's a reason for this. I think it's good to have a backup just in case you have challenges doing things, as an example, with your tools. You can always use an external tool to do a lot of stuff, actually, not just Git and GitHub, but other things. So there's Gitkraken. So please download that and install it. It's free. And when you do, I want to bring up mine. So here's Gitkraken. It's going to make this nice little animation. It's going to bring this up, and you can see that it's going to give me some stuff. Okay. So you'll probably see it come up like this because you've just started using Gitkraken. I'm going to wait, and when you're ready, if you can kind of check, use a check mark here to let me know in the participants panel that you're ready and you're with me, and then we'll continue with Gitkraken. You've downloaded and installed Gitkraken. So there's a couple things to do here. Notice that when you guys are ready, I'm going to just go through this. There are open a repo, clone a repo, start a local repo, GitHub, grab something on GitHub, which you can totally do, and so on. So you can actually clone. This is a clone. You can also connect to GitLab, Bitbucket, and Azure DevOps. These three also use Git as an example, but they're just alternatives to GitHub. All right, so again, are you with me? Have you downloaded Gitkraken? Check mark for yes, X for no, please. Daniel says, thumbs up. Nicholas is almost. Ryan is with me today. That's awesome. Thank you, Ryan. Got Dominic. Seeing the hands come up. Dewey. Awesome. Okay, I'm starting to see hands come up here. All right. I'm going to continue. Hopefully you guys are going to catch up. There we go. All right, thank you for that feedback. All right, so I'm going to go to this now. So now that I've got this, I want to, where it says start a local repo, I want to go here. All right, so instead of using the tools built into IntelliJ, let's see how smart IntelliJ is, okay? I'm going to keep this up, but remember where this is. You can always find your implementation. If I go to right-click on Source, SRC, right, and I want to show an Explorer, that's right there. If I show an Explorer, you can see it takes me to this file structure, right? So I need to go into OOP3200. Wherever you have your files located for lesson 11, I want you to come out one step to a folder just above that. That's where it's going to be. All right. So when you go into Gitkraken, you're not going to go into lesson 11, whatever that's called. You're not going to go into this structure. You're going to be outside of lesson 11 here when you specify where you're looking. Okay. So if I'm looking for OOP3200, I'm going to be in this folder, not inside here. If I'm inside there, inside our lesson folder for today, it's going to make another folder in here. We don't want that. Okay, so we want to be out here. All right, so if I go to Gitkraken now and I go to start a local repo, here's where we go. We're going to click onto it, and it's asking me, okay, where am I looking? So I'm looking inside of OOP3200, not inside lesson 11. I want to select that folder. Okay, so cool. That's the outside folder. Now, I'm not going to initialize it here. I'm going to make a new name. And the new name that I'm going to put together is the name that I'm going to put up on GitHub. So it's going to be OOP3200, right? And again, dash F2020, and then lesson 11. What I want to do is I want to match this name with the actual folder that I have that I'm using right now. So again, if I'm OOP3200 F2020 lesson 11, if that's what you called it, then that's what I'm going to put here on Gitkraken. Right? OOP3200 F2020 lesson 11. Okay, now a couple things. It says default branch name main, Git Ignore template optional. Let's put one in there. So let's see if we can find one. And if I look for Java, you can see that there's a Java Git Ignore file. All right, so we can click on that. But let's look for other ones. There's also, if I start talking about Intel, there's nothing like that, right? So there's no Intel. Put Android, there's Android if you're going to cook with Android. We're not doing that. App Engine if we're going to do that. But what we need is Java. We can also put a license if we're going to license our app that we're making or whatever. We can also initialize the GitHub repo with large file support. Okay, which if I had larger files, like for example things like images or large textures, meshes, three-dimensional meshes or something like that, then I would definitely do something with large file support. Otherwise, we're good to go. That's all you need to get going. If I click create repository now, it's going to initialize and it's going to give me this really nice little map. All right, so this little map right here is going to show me which branch I'm in. I'm in the main branch. It's going to also show me that I've got some files. Here's some files that have not been added, to my commit. All right, so I need to. These are 9 unstaged files. 9 unstaged files. So if I click on Stage All Changes, this is like a git add dot. Okay, and now I'm going to say things like, in the commit message, I'll say added file, project files. So these are all my project files that we've done. Notice that this is where it's at. So all I did was, again, I just went to unstaged files. I added them. I have all these files here. And you can always unstage if you don't want some. Let's say, for example, I have this like this. I can always stage or unstage. You can kind of toggle that on and off. It's not a problem. It's very flexible. And then what I've done this, then I can go to commit to 9 files. So I do that. Here it is. And now you can see this my little picture here because I've allowed that. And then you can see this is my main, the head of my Git repository, and it's pointing at added project files. Okay, let's pause here for a second. I'm going to go over to IntelliJ and see what I got going on. Whoa, look at this. I got a Git Ignore file here. And I got a readme.md file that I can actually look at. Here's my readme.md file. It says OOP F2020 lesson 11 is what it comes up with, right? Markdown, which is MD, has the ability for me to put in, some markdown. Notice that one hashtag that I put in, this is inside of my IDE, IntelliJ IDEA. It shows up here, OOP3200 F2020 lesson 11, and actually, if I put 2 hashtags, then it's going to make it a smaller. It's almost like an H2 tag in HTML, but here we're going to put 1 hashtag. It's like an H1 tag. Cool. So that's there. But one thing that didn't get picked up, if you notice here, because IntelliJ has its own way of doing things, I've got a Git Ignore file that appears here. If I click on the Git Ignore file, it shows me all the stuff that any compiled class file, right, it doesn't want up there. Any log file, any CTXT, BlueJ files, mobile tools for Java, jar files, kind of anything that's zip files or anything like that. These are all things that will be ignored. That's what a Git Ignore file does when it's inside your structure. Okay. Cool. But oh man, if I go here, it says enable version control. Like, it didn't pick it up. And this is the thing where you use an external tool. I'm putting it out there for you because you may have attempted to do that in the past. Yeah, I know. I hear what you're saying, Jackie. And once you make a repository here, it won't allow you to do it again. You have to delete it. The way to delete it, if you made a mistake, and this is the way to fix this, again, you can right-click. You can go to Show in Explorer. And if you see a .git folder, right, just delete it. Just delete this .git folder. All right, this .git folder will allow you to, it'll ignore stuff, right? So you're good to go. If you just delete this .git folder, you can start it over again. This whole process that I just showed you, because the .git folder keeps track of, your, the latest stuff, like where your Git repository is. This is your Git repository in effect. Now let's take a look. I'm going to compare this structure before we move on to what we had before. So if I go to lesson 10, Git, hey, we have the same structure here, but somehow IntelliJ did not pick up this time. Like if I look here, it looks like it's not really initialized. Well, so here's what you need to do. All right. Because, again, one thing you have to consider is that this is trying to figure things out. Well, there's this nifty thing called reload from disk. So what if I did this reload from disk thing, right? Will it pick up the fact that I've got a Git repository? No. What about if I stop IntelliJ? So I'm going to exit, and then I get back into it. So I kind of open up IntelliJ again, and I go back into that folder. Does it pick up the fact that my project is under VCS? And the answer is version control. And the answer is it does. See, look, I can do a commit now. And before it didn't. So that's the only change you have to make. You just have to restart your project if you're using an external tool, and you're good to go. It'll reload. It'll pick up the fact that there's a .git folder, and you're good to go. All right. So you can actually resume with VCS inside of IntelliJ if you wanted to. But we're not going to do that. We're going to continue with the external tool that we've been using, Gitkraken. All right. Now I need to push this out to GitHub, and there's an area here on Gitkraken called remote. Here's remote, right? And what I want to do with remote, and by the way, notice for me, there's this check mark. I got check marks here. All right. You may not have these check marks. If you've never logged into Gitkraken before, it may ask you to authorize, GitHub. It'll ask you to log in for the first time and those kind of things. So please follow the instructions when we go through this. Just authorize Gitkraken. Once you do, then it should be very, very straightforward. But you should have the check mark here. Thank you, Nick. So if I go to remote, if I click plus, then what it does is it says, okay, select an account. And I have my accounts here. I can select my accounts. So I want to see, and by the way, if it doesn't show up here, right, as an example, like Durham doesn't show up here. I've got the other ones here, but what the heck, where's Durham? Kind of thing. That's okay, right? So again, you can always go with a URL. Even if it doesn't show up, you can click on URL, and all you need to do is what the URL is to connect your remote. Okay, that's the only thing. However, what if, as an example, it didn't work? Well, let's see what happens. First of all, first and foremost, let's make a URL up on Durham Programmer. So we need to go up here. So Durham Programmer, I'm going to make a new project, right? So example for me, I'd make a public project. We're going to call this OOP3200 in the F2020 semester, and then it's ICE 10, where this is going. This is going to create a new repository for me up online. And now I've got this remote. Here's the link. So I click on the link. I go back up to here. I put the link in there. Notice it's copied. You can make a different pull and push URL, and then you can name it whatever you want. So I can say something like OOP3200 F2020 and then ICE 10. You can do this all manually if you want. And then if I add remote, then that is what it's called. It's not normally called this. It's usually called origin, right? but that's remote. What about if I want to edit the remote? If I want to edit it, I can just change this to origin, which is what it's normally called, and then edit remote. Notice that the origin remote there is there, and it's connected to what I got. And if you look, there's a little hide and graph if I want to. But what I want to do is I want to push this out to the remote now, and all you need to do is go here and say push. So I mean, I'm trying to help you with problems or any issues that come up, but let's just push. And when you do that, it says, what remote branch do you want? Push into main, submit. If I do that, then what it's going to do is, if it push failed, it says, make sure you have access to do this action. For me, I need to actually authorize myself to do it, and that's why it's causing me to have a problem. I'm going to grant permission, because if you haven't authorized, it'll give you this issue. Let's also do it with Ontario Tech, because I'm also there, right? And if you have that problem, it's not a problem. It'll just take you to organizational access or your account access, and it'll fix it in a jiffy. Let's try that again. So again, if I want to push, I can do so, and if I have a problem, it'll tell me. Now, when I do so, it says push successfully. This is great. So even if my problems, I had problems, you didn't, but I'm good, right? Look at this now. I have two things here. I have main here, and there's two symbols. One is the symbol for Durham, and the other one is a symbol for me, the computer locally. This is great, guys. This tells you that I'm synced up locally and remote. Okay? What if, though, I change stuff remote, on the remote? Let's say I'm working with a partner. Well, if I go with here and if I refresh, here's my GitHub folder online. I know I'm spending time with GitHub, but guys, when you're working on a project or a lab, people have come to me, not just one person, and said, hey, how do I do this? I'm having a problem. So here's my README up online, readme.md. And let's say I have my partner is modifying some files. They're just going to modify my readme.md. I'm going to go in here and change that. And I want to add in a hashtag for this, hashtag, right? OOP3200. I'm changing it online. And then locally, I want to say something like demo project for OOP3200 at Durham College. So I'm actually changing it online. So this is actually going to be different, than what I have locally. So I do this, I commit my changes, right? And I have something that's up here that's different in ICE 10 than I had locally on my machine, right? It doesn't show up here because remember, GitHub is not, there's no state when it comes to GitHub. Git and GitHub, you're not always connected nonstop, right? So what I want to do here is I want to go to where it says pull. And if you're not sure if your partner's pushed anything to GitHub before you start work, you can go here to pull, and instead of pulling his stuff, you can actually go to fetch all. When you do, it'll show you a couple things. Look, here's main, that's me locally on my machine. And here's main on the origin remote. So the remote on GitHub, this is me locally. I'm one commit behind the remote on GitHub. You see? I'm behind. So this is where the head of my branch is, right here locally. But look at up here. It knows that there's another incoming commit if I want it. It's called, it's kind of on this branch. So what I want to do now is I want to pull fully. And when I do, if there's a problem, it will try and merge. Now here's the thing. Remember I modified this locally? I got a merge, right? And it says, I got a problem, as an example. And let's see what this problem is. It says, I want to do a merge conflict. Okay, so if I click on this, right, as an example, it will try and resolve my conflict for me, and it did. It actually did my merge resolution for me, so it actually fixed my problem. It's amazing. Why? There's not a big clash. Now look at this. I still got a bit of a problem, right? Because I've merged my branch, right, and I've got another line of stuff, and it says unstaged changes. I want to stage those changes, and what I want to do, it says auto stash and whatever. I want to put a little commit message that's like merged, files from GitHub. Let's stage those changes again, and then commit those changes. There we are. We've merged everything together. Notice that I made a merge, right? Well, it says auto stash, but let me see what happens here, and let me push that back up to GitHub. Let's see what that does. Did I mess things up? What did I do? All right, let's go to GitHub and refresh. Did I lose my stuff? No. Right, everything is good. How about my files? Did I lose my files? So if I go to inside my source, no, we're good to go. It's all good. So this is pretty good, right? This tool helps me fix things up, right? It helps me, do some merging. If there's a merge conflict, it'll tell me, because remember, locally in my IntelliJ IDEA, and now you can see what my files look like. Now it's kind of the same, right? Notice how it's good. We're good to go. All right. All right. Let's see how this works if I'm actually going to do some work now. So we did some. We'll keep Git Kraken open, right, to help us allow this. Again, this is a great way of visualizing who did what on your branch and all that kind of stuff when you're working with a partner. That's why people use external tools. Again, I'm not really a fan of it in terms of, only using this. I think it's great for things like merging and any kind of conflicts. I think it'll help you do conflict resolution. I think that's good. But let me go back in here and start something else. Okay, so last day what we did was we did this main stuff, right? And what I want to do is let's think about some kind of random number thing. I want to get a random point, right? Instead of me doing what I have here, right? My vector2D class, I want to get a random point that it generates. So I want to generate random vector. That's what I want to do. And there's a couple ways I can do that. I can definitely make a do it in a function, but let's make it a little harder for ourselves. We'll do a little bit of maybe a contrived example, but I want to make a new class, and the new class, I want to make it so that I don't have to instantiate the object in that class. I want to kind of use that class as almost like a static class. It's almost like once I use that class, it'll be the single source of truth for my files. Okay, like a utility class, if you will, a global class. So there's a couple ways to do that. Let's explore a couple of ways here. So I want to go into my files here, and I want to add a new file. I'll add a new class here. Let's do that together. The new class I'm going to add in, again, I want to call it, and I want to think about this, what this is. It's like a random vector 2D class. That's what it's going to do. And I'm going to have a method I'm going to call that is going to be called generate. All right, and the generate method is going to return back or create. We're going to create a random vector, right, between 2 points. I'm going to give a kind of a starting position and an end position, 2 points, right? And I want to generate a vector inside that range. That's what I want it to do. Okay, so for testing purposes, this is much better than what we're doing because we're actually entering the same data every single time. And what if I want to have a bunch of different data that's randomized, so I can pick up some errors, so I can do some testing with this thing. That's why I'm doing it. Okay, so let's think about the name for the class. Let's do this together again now. All right, so what are your recommendations? If you're going to make a class, now you've done C++ and you've done Java, what do you think is a good name for the class? We could call it random vector 2D, right? That's something. Random vector, Nicholas says. Random vector, the thing with that is we could have a random vector 3D, right? But that's okay. I don't mind random vector. Maybe we can have another type of class that is something that we want to make too. Random vector is more generic. Vector generator, okay, Kafkan, no problem. Anyone else? So remember what we're going to use. This is the syntax. I want it to speak to you when it comes to writing the code. So I have a class name, and then I'm going to have a method that it's going to do what it's going to do, right? Random v2d. V2d is okay. The problem with v2, it doesn't really tell us what it is, Nicholas. I'd rather err on the side of let's make it so it's a larger name. I like your original one. I like random vector. Vector generator is okay too, Kafkan, but I like random vector because at least we know that it's random. We don't know what kind of random vector, but that's good because we can make it more generic. So let's call random vector. So here's our new class. Let's do it together, guys. All right, and I'm going to make it a class. It's going to generate this thing. It says add file to Git. Remember, don't ask again. I'm going to say add for sure. I want to keep track of it. So it's going to be tracking this file. Again, we want our IDE to help us with that anyway. Okay. All right, so what does this random vector class do? Well, I want it. Let's explore one method. The one thing we can do is we can have just static methods, right? So instead of actually using random vector as an actual class, we can have a static, so public static, let's do this together, method that we want. This also works in C++, by the way, called something like create. Okay, I want to create the vector, and I want to specify what type. So random vector dot, that's how it'll be, dot create vector2, as an example. So we'll say create vector2d, right? And we want to give it a start and an end, so between 2 points. So we need to take in a vector2d, the beginning point, right? So start, and a vector2d end. So between 2 points, we're going to do that, okay? And we need to have a return type. It's going to return back a vector2d. Okay, so public static vector2d, and then it's going to do this. Now, here's something I want to point out to you. I haven't made a constructor, right? And because it's static, I don't have to make a constructor. And because it's static, this is like a utility class, random vector utility class. So there's good and bad things about this, right? It can still be, if someone doesn't know how to use my class, by the way, I'm not filling in the details here for a second. If someone doesn't know how to use my class, they may go and try and construct it, right? They may try and make one, like a constructor for this class, and mess up my files somehow, if they don't know how to use my utility class. So I want to control global access to this class. I want to control global access. And one of the ways to do that is to create a singleton. We'll talk about that in a second, and you guys should know, at least have heard of a singleton, but if you don't, first of all, have you heard of a singleton? Check mark for understand, or X, you don't know what a singleton is. Chuck says no. Ryan, no. That means there's a couple people already. How about anyone know what it is? Is there any check marks? No. Okay, we'll do it together. There's enough no's that people don't know. So I want to make it a singleton, but first let's make it so it's not a singleton. So how does this work? So I want to take a vector2 start and end, and then what I want to do is I want to create a random number between two points. Well, let's use some kind of a class. So I want to import, let's do this first, java.util. And I want to use random, right? So here's this is the class that I want to use, Java util random, okay? And what I want to do is random will produce random numbers between, kind of one state and the other. And I want to do that here inside my vector2. So I'm going to say something like random, rand is equal to a new random object, right? And what this does, this is an instance, right, of the random class. Again, we're talking about classes and how to use them in Java, right? So this is kind of relevant. Once I make a random number, this random number is going to produce anything that I want, okay? So for example, maybe what I want is I want random floats, because vector2s right now in our hierarchy, if you look at our vector2 class, we're going to just jump over here. It's a floating type. We haven't made a generic type floating vector2. So we know we're going to need floats. So what we're going to do is we're going to say here float, and I want to get a random float. That's what it's going to be called, random float. And that's going to be equal to rand dot next float. Okay. And what that's going to do is going to just kind of grab the next float that I want, right, as an example, and store it inside of there. Now, let's think about this. If I do random next float, if I hover over it, it says returns the next pseudo-random uniformly distributed float value between 0 and 1. Okay? Between 0 and 1. I'm going to get numbers, start and end, right, in here that I need to do it. So I could do this, right? But what I really want is a random float between whatever my vector2.x is and my vector2d on my n.x is. So let's do that. So we're going to call, instead of random float, we're going to say random x value, right, is going to be my next float, and then multiplied, and I want to get a random number between these two states. So the maximum it's going to be is the end. But what about if it's like, you know, I don't know what the minimum and maximum values are for this number, right? So I kind of want to have almost like a minimum and maximum float. I want to know the min and the max, right, from these two values. So, and hear me out, because I want to kind of range. I want to get a range between of these random values, right? So when I'm thinking about this in my mind, I'm thinking about I need to use a math min and a math max. So we're going to call it float. We'll say min x, minimum x value, right? And we're going to say that it's math dot, and I want the minimum, right, between two values. I want to get the minimum between my start dot x and my end dot x. Okay, I want to get those values. Now notice that it says get x, and I want to do get x because remember we made it so that you can't access x and y. It's private in our example vector. So that's the minimums. We have a minimum x. Float, right? We have a maximum x. I want to know that. So max x, right, is equal to, and this is just preliminary. I don't have to do it this way. I'm doing it because I want to use classes, built-in classes. So that's why it's a contrived example. So again, I want to start dot get x, and I want to end dot get x. Okay, so there I've got minimum and maximum values. I've kind of done this twice, but it's okay. All right, so I got the min and the max. Now, what I want to do is I want to multiply it by the max. So I want to say something like I want to multiply it by max x, right? So 0 to 1. This is going to give me a number between 0 and 1, right? Multiply by max x, right? And I want to add min x. So I want to say that this is what I'm going to get plus min x. All right, so now I've got my random x. Are you with me? So this is going to generate a number just on the x's between the minimum x and the max max. I don't know which one is min and max. Doesn't matter, right? But I want to be able to generate a number between these 2 points. Right? Now, math. If you think about it, right? That means it's going to be a large box that I'm hitting a large area, right? That anywhere between these 2 points, right? Nothing outside those points, right? But anywhere inside the x values and inside the y values, which means it's a rectangle, a rectangular area that I can get, you know, x and y coordinates. And that's the way my vector2 create vector2 is going to work. All right. I like it. Let's see if I can grab this as an example, and I'm just going to copy it, and we're going to do the same thing for min y and max y. So min y and max y. I'm going to do get y. Again, there's other ways to do this. And why not? We're going to do it like this. Lots of extra variables here, and we're going to try and refactor this, and I want to talk about how to make this sleeker if we can. Okay, random y, we want to get it from max y and min y. Okay, so is that going to give us our numbers? Maybe. So this is the y's. So this is going to generate random y value, right? And this is going to generate a random x value from min to max. From min to max, right? That's what our value does. We have to make sure when we document this thing, right, we should specify to everybody that it's clamped between the minimum and the maximum value, all right? And then what I want to do is I want to return a new vector of that type. So I'm going to say return a new vector2d, where I pass in my random x and random y values. Are we good? Do you agree? Do you agree? Do you not agree? Do you think did you do it differently? What would you have done here? Is it even going to work? What do you think is going to happen? What are your thoughts, guys? So Nicholas, I see a check mark. Anyone else have an agree or disagree? Would you have done it different? You guys are programmers, right? You imagine you're in an interview. Nick was just on an interview. You're in an interview and someone asks you to do this. I want random values between two vectors. You know, as an example, I want a method that does that. Give me a method. Is this okay, or would you do it differently? Is there another opportunity? Do I need to do this? Nick says it's acceptable, but do I need to do this? Right? What if I said I want to multiply it by one vector, but the vector could have a negative number? You know, remember, you can have negative numbers in here. Vectors can go from a negative value to a positive value, and negative infinity to positive infinity. I can put in here, and there's no checking, so we don't know about if it's a weird value or whatever, and it's just going to produce a random vector. Okay, great. So let's suppose it works. So math.min, that's a very good question. Math.min, what it does, it takes a look at, if you hover over, it takes a look at it returns the smaller of the two values. So it says, okay, now I don't have to do it this way, right? I could actually not use math.min and math.x. I'm actually doing it twice, right? So because if I know what the min is, I know what the max is. I don't have to do it this way. I'm just doing it to be verbose. This is like really crazy. It's not necessary, right? But let's suppose I'm doing it this way, and we can refactor to make it better later, okay? And maybe this is the first way you thought about doing it, right? Okay, cool. So we've got a vector2 as an example. I'm doing it. I'm not actually creating a new object. I'm doing this thing, and it's public and static. Let's test this thing in our main. So I go back to my main.java. I want to use random vector. So instead of me entering, the second number, right, or the, kind of the first number, it's going to prompt me from my first point, right? And what I want is this thing is going to generate a number between two random, it's going to generate random values, right, between the first point and the second point, right? It's the first point and the second point that I provide. And instead of me entering the points in here, this entering the first point and second point is going to be from my random value generator, right? So I want to generate a random point in space, right, in two-dimensional space. And then I want to generate a second random point in two-dimensional space, right? And then maybe get, kind of use some of this, the second point. So let's do that first. Let's repurpose some of this stuff. So you enter the second point, and instead of doing the magnitude and all this kind of stuff, the distance between these 2 points, I don't really care about that. What I want is I want to use again. I want to comment this out. So let's just comment this out. Actually, we'll just use a block comment to do that. Okay, there we go. There's my block comments. So I get the first point and the second point, and then what I want to do is I want to use my random vector. So random vector, and the way you can use it is dot create vector 2D, right? Create vector 2D, and it says not null. I need to put something in there from two vectors that I need to create. Okay, so I know I have point 1 and point 2. So point 1 0.2. So those are two vectors, all right? And what this is going to do is, if you notice, if I hover over vector 2D, right, it's going to return a vector 2D. That's what it's going to do. It's going to take two values and return vector 2D back out. And so I need to make this new vector 2D object, right? So I'm going to say vector 2D, and my vector 2D is going to be called random vector, lowercase. So that's going to be my random vector. We'll call it random vector 2D because just to keep it very simple, right? Random vector 2D is going to be this random vector, and I want to show it. I want to kind of print that out. So how do I do that? Well, it's going to be something that looks like this. So system.out.println, right? You know, you entered, this kind of stuff is what I want. So I want to grab this. And instead of you entered, we can say the random vector is, and then it'll be random vector.toString, random vector 2D.toString. Let's do this first, right? And that makes sense. Okay, so we're going to get a random vector, and once we've done that, we're going to have, you know, whatever. We're going to show what this random vector is and see if it works. Okay, let's try it. So, boom. And let's see if it compiles. It does. We're going to get the first vector. So we'll say, okay, I want a vector between negative 15 and positive 80, right? And the next vector is going to be positive 25, right? And negative 28. Okay, so notice I'm just putting in really random values, and I'm switching I'm not making it a whole negative vector in any way. It's going to be like kind of from a negative, on the negative side to the positive side. All right, so I get a random vector, it says, it generated it. Let's see if this computes, right? It gets a random vector between minus 12, it generates a random vector minus 12, minus 24-ish. Okay, that's what it did. Minus 12, minus 24. Does that compute? Well, minus 12 is within minus 15 to 25. So that computes. And minus 24, is that within minus 28 to 80? That computes. So that is how this works. So it'll generate a vector within this box that I've made. I've kind of specified a box, right? And again, if you think about what I'm doing, and I'm just going to draw it out just quickly, and then we'll move on from there, and we'll talk about the problems with this approach, right? So here I've got, this is my area, and let's suppose I have some, we're going to draw some axes here. And we're assuming a Cartesian plane, all right? So everything is fine. And if I go back and if I say, so minus 15, let's suppose that is going to be somewhere over here. Let's say, and it's because it's minus 15 to, let's say my scale, because we have up to 80, we'll say this is 100 on the negative. So this is negative 100. Everything will be 100 approximately with some skewing. Negative 100, we'll say this is 100, even though it looks weird. Let's say there's some, the pixels aren't exactly even, negative 100, 100, and the bottom part will be negative 100 over here. So if we know this, and this will be 100, positive 100 over here. Okay, I'll put them in there. So negative 100 to 100, it's not exactly even. It looks more compressed here. That's okay. Don't worry. I just want to draw it so we have some kind of ratio, as an example of points. Maybe the points, there's different, compression, like I said. Whatever these points mean. All right, and suppose that I wanted to draw this vector out. Again, we're testing our options. So I'm saying that I want to get, my starting point is negative 15. So this should be 50, that's 25. So somewhere, let's say in here. So this is my starting point for my x-axis. Let's put it an actual up and down line. Approximately, let's say. This is where it approximately is. And 80. So again, it's let's say this is 50, this is 75, it's slightly above that, so maybe somewhere here, right? So we're looking at a point roughly, if we're drawing it, and I know this is not a math class, please bear with me. So we're saying that the point is here, all right? And that's our first point, right? Negative 1580. Second point is 25 minus 28, or negative 28. So 25, that's easy to kind of figure that out. We know that this is approximately 50, this is approximately 25, so this is the first point on the x-axis, 25, and then the other point is negative 28. So again, it's 50, roughly 25, a little bit more like this, so something like that. All right? So this is our range, okay, that I've created with us, right? A random vector, which is roughly from here to here. So what we've really done, if you think about this, like I tried to point out to you, let's use another color. We'll use a color that's, let's say, bluish. What we've really done is we've connected these 2 points in a box. We've kind of we said that our vector can be anywhere in there, the way we've made it. Okay, so anywhere in there in two-dimensional space is where we want our vector to appear. Any point in that thing. Anything is valid. Okay. Are you with me? I'm pointing this out only because I want it from testing. I want, this is just to make sure that we're getting values that are real, right? Thank you, Nicholas. Some other people are getting it. Good, good, good. Again, I'm not expecting you guys to remember math or even like what I'm doing. I mean, I'm a game programmer too, so I always try and think of these kind of problems. So I've done this. Here's my random vector, and I want to do this again. I want to kind of generate another random vector, and I want to do the distance between two vectors. So that's what I want to kind of do. But I have a fear. I fear that I'm going to give this little utility, random vector 2D. I'm going to give this utility to somebody, and they're going to try and do random vector is equal to a new random vector. Can they do that? Can I do that with my code? Can I say something like, I want to make a random vector, we'll call this random vector, is equal to a new random vector. Can someone do that? And what does that mean anyway? Guys, it means nothing. It means nothing. There's nothing inside my random vector class. Really, my random vector class is just a container class. That's all it is for other functions that I want to use. So there's a couple of approaches here. One is I can create a package or a namespace equivalent and make a bunch of functions in that namespace. Or I can use something called the Singleton design pattern. So let's not do this. So we're going to limit it. We're going to control our global variable. This is what this what this is, that random vector. So inside random vector then, let's go back inside here. I want to rejig this class. I still want to have this public static thing, kind of. But instead of making it public and static, I want to control how this is created. So what is a singleton? Think about it as I can never create more than one instance of this class, ever, right? Even if someone tries to make a new instance of the class, it doesn't matter. I can control the instance. And when I make an instance of the class, it'll give me access to its static members, but only then. I'm forcing my instance to be created. So this is a good thing, because what if this random number that I just made, as an example, I'm just creating a new object here. And what if I wanted to share my random object amongst all of my entire class? I can't do that here. I'd have to make new random numbers. If I had another public static, let's say I wanted to make a public static vector 3 class, a create vector 2D, a 3D. Well, then this new random object I'd have to make again and again and again every single time. And every time I call this class, I'm making a brand new, I'm allocating memory and deallocating memory over and over again. All right. So what if I want to share this? I want to, have something that's shared that I want to use. So the way you make a singleton is you have to do a couple things. One, you have to declare you have to make a private static instance member. Okay, so what you do is say private static, and you call the new private static instance. So we're going to say m underscore instance, right? And it's going to be of type random vector. Okay, and we're going to set it to null. Okay, so private static instance member called random vector, or of type random vector called m underscore instance. Okay, so again, this is a pattern that we're creating now. Next, I also want to make the constructor, the default constructor, private. Default constructor, right? If I can spell default properly. I want to make default constructor private. Why? I never want anybody to be able to use the new keyword here. I want to be able to control when they make the new keyword, when they use it. So here I'm going to say that private, and I want to call the new class random vector, right? And this random vector is just going to literally sit like this. So it's my default constructor now is private. That means no one can do new, they can't use the new keyword anymore. Okay, I don't have to put anything in here right now. I can keep it empty, but I'm not going to. We're going to see this in a second. Next, I need to make a, so these are steps. So we'll say step 1, and this is step 2, right? And here's step 3. Step 3, make or create a public instance method that acts as a, we'll call it a portal to the class. Why am I thinking about a portal or a bridge or a doorway, whatever you want to call it. The only way that someone can access my class members is through this portal, all right? It's not really a portal, it's just a method, all right? But we're going to make it public and static. It's going to return a reference to my random vector, right? And we're going to call this, now there's two names normally conventionally we call this. It's either instance or get instance. So we'll call it instance in this case. So here's my instance method. And what it's going to do is it's going to check to see if m underscore instance is null. If it is, then we're going to make a brand new, we're going to allocate memory and return a new instance of the class. So how does this work? We're going to say that if m underscore instance, if it's equal to null, right? So if instance is equal to null, then what I want to say is m underscore instance is equal to a new random vector. And what we're going to do, regardless, is return m underscore instance. Okay, let's take a look at this structure, and so you're not confused. So instance is going to return a reference to random vector. Think about this as a pointer. Okay, I'm returning a pointer to random vector. If my instance member, my private instance member, is null, then I want to create a brand new, I want to allocate memory, right, on the heap. I want to allocate memory, and I want to save a reference to my instance member here. Okay. What about if I try it again? Someone calls my instance method again. If they do it the first time, it gets created. The second time, though, it's not null, is it? The second time, no, I just returned the same instance back. Hence the singleton. I never return more than the single instance or single reference to the same class ever again, right? And this controls global access, right? And this also allows me to basically to not instantiate the method. It's a better way in some ways of creating a static container class. Now, how do I use this? Create vector2d. I wouldn't make this static anymore. So this is not static, right? So no more statics. And we know there's a problem with this because it says related problem, because the way we've called it outside of this class, right? We are assuming that we can use this the way that the class was made before, but we can't anymore. Okay, we have to modify our access to this thing. It's the same thing that we did before, right? However, we're going to fix this problem. Okay, so let's go into our main to fix it. This is where the problem is. This is what it's detecting. It's saying, wait, it says non-static method, this is trying to be used, and no, you can't do this anymore, Tom. All we have to do to make it work is put in front of this instance. So let me try that again. Instance. So this is what I want if I spell instance right. This is what I want. So now it's going to be a little longer, but it's going to look like this. Random vector dot instance dot create vector 2D. In other words, in order for me to create a vector 2D, I've got to go through the instance gateway. That's what I like to call it. It's not really the thing that it's called, but think about it as the portal. I need to go through this method to get to this. Why? Why would I want this? Why? Because you're going to be like, why? It's way easier just to do a class. Yeah, but I don't want the class instantiated. It's just a container class. I might have other methods in there. I can never do this anymore. Watch this. If I say random vector is equal to a new random vector. Now it's going to say, wah, sorry. It says random vector has private access. It will not compile, ever. That means I can prevent the error someone would make about trying to create a new instance of the class when there's no real need for it at all. The only way that it can be used is through the instance method. Okay. Let's see what effect this is going to have on the entire program now. Does it still compile? Does it work? What does it work like? Let's run this thing. Right? So, yeah, we're still okay so far. So again, I want a variable between, let's say, -50 and -50, right? That's my first point, and my second point is going to be positive, 80 and positive 30. All right, does this compute? Does this compute? It has to be this number is 15. It goes from a -50 to a positive 80. That's in the range. Okay, and it's going to go from a -50 to a positive 30. -40 is in the range. So this is a valid vector, and it worked. All right, let's do some documentation here, so you understand what I've done, right? My random vector. This is actually a singleton. You've seen now a singleton in action. This is a singleton. And these are the steps that I've taken. Okay, question. Can I move this, right, in here? So whenever I make a random vector, I create the singleton, this rand, but I can hold instance variables now. Not how I wouldn't be able to do this if it was a static class. I can't share anything in a static class, really. We just have to be other statics, right? So I can do something like random rand, right? And then I can say that rand is equal to new random. I can do that here. So this is kind of in here. I can make this private too, so I don't have to hold on to it, right? And what I can do is I can refactor this thing. So let's refactor. So I want to refactor. I want to rename this thing to m_rand, right? m_rand, right? So now I can do this. So I can create a private instance, m_rand. Here inside of my constructor function, right, I'm going to instantiate an object of type random once, right? Because that's my, remember what we're doing. When we make random numbers, we're not really making random numbers. What we're doing is we're getting a sample of a pseudo random number from a map. That's what's happening. So there's a big, massive, let's say a list of pseudo random numbers, and all I'm doing is sampling from that list that's predetermined for me, right? Kind of how it works. So I never really make random numbers. I'm just moving my pointer around to another place on the list. Okay, that's what it's doing. So I don't want to do this twice because this is a waste of memory, right? can this still work, right? Because it's the same thing, but now I'm using something that's not in my create vector 2D. All right, cool. And let's do this again. Let's go back and run the code again and see if it still works, right? Because remember, even though I don't have access to my constructor is being accessed internally, right, by my instance variable. That's happening up here. Inside of my instance method, I'm accessing the default constructor. The default constructor is generating the new random instance of my random class, right? Okay, let's try this. So again, let's do a different number. So 0, 0 this time. I'm going to go from 0, 0 to 100, 100. Okay, and let's see if it works. 89. Whoa, that's like really close to 0. 89, 0. What? Why do I have this thing here? Did I make a mistake in my random vector in my toString method? I think I did. Wow, no one even noticed it. Heck, I just noticed it now. You guys didn't even say anything. Right? All right. Well, let's see where that is. So here's my @override. Look at that. I have a curly brace instead of a paren. You noticed? You didn't say anything? Damn. All right, there. I've updated it. I didn't notice it. I just noticed it now because I'm thinking one thing and then I'm not looking. But that totally worked. That's what I'm saying, right? It totally worked and it's not an issue. You totally didn't notice. Oh, yeah, I noticed. All right. I just noticed now. Okay, so it totally works. So let's review what I just did. So random vector then, if you think about this, random vector is a singleton. Singleton, again, it solves two problems and it kind of breaks one of the solid principles, right? Solid principles, one of them is the single responsibility principle. This breaks the single responsibility principle, the singleton. Why? It solves two problems. The first problem is it controls global access to an instance of a class. So only one instance can ever be made of my random vector class. Ever, ever, ever. Okay? That's the first problem that it solves. So, and the other one is it creates an instance, a single instance, right? So because it does that, right, and there's only ever one instance that can ever be made, plus global access, this becomes an issue. This becomes a problem. All right, a couple things too. We can adjust our create vector 2D. We want to make it so that two things can happen. One, we want to make our vectors that come in inbound final. We never want them to be modified. Okay, let's see. I'll try it out. If we can make two vectors. All right, so we want to make it final. And also the other thing is, here's something else. What if I never want this method to be overwritten? I don't want an override for this method. If anything inherits ever from random vector, my create vector 2D is going to stay static. I can do that by doing final in front. If I said private final, this is like const. It's kind of a final method. This method can never be overridden. Look, it's making a recommendation here. It's saying change my access modifier. I don't want to do that. And here, if I click onto this, it says insert not null on parameter start and end, right? So if I did that, it says make inferred annotations explicit, da-da-da-da-da. It asks me to download it, sure, and yeah, I'll get the Java docs and the sources and annotations, no problem. And what this does is it's making it so that this is a way of doing it. Private final not null, which means it will not accept a null variable in here. You have to get some stuff in there for it to do this. All right, so again, some extra stuff. Notice that up here, it also included Jetbrains Own Annotations. This is not portable. JetBrains. It's only from JetBrains that allows this to happen. So I like it if you're always going to use JetBrains IDE, and I don't like it if I want to port this to something like a Mac or a Windows machine that doesn't use JetBrains ID? What if I wanted to move this tomorrow to NetBeans? That wouldn't work. So that's why I don't like it. All right, so I like it and I don't like it. I'm making recommendations, but I don't need it. Okay, let's make it so that finally we'll make it so I can take in 2 points. Nick's saying there's an issue. Let's see if there's an issue. All right, so again, if I go to main, I want to loop through this twice. All right, so enter the first point and the second point. Okay, so this is going to be a random vector here, and then the second random vector is what it's going to be, right? So I want to say this random vector instance from point 1 and point 2 is going to be generated twice, and random vector 2D, this doesn't work. It needs to be done. There must be, you know, kind of like these 2 points that are generated from point 1 and point 2. So again, there's a couple ways of doing this. I could have an array of points that I keep track of, right? A small array of points, a point array, or a list of points, right? And I want to go from 0, 1, 2, and so on. And let's see what Nick has, a little download for a capture. Let's see how this works. Open the file. This is what Nick's capture is. Thanks, Nick, for that. So this is what Nick did. Okay, get instance, point 2, and use point 2 and point 3 and point 4. Okay, and what's the issue that you're getting? On point 5, point 3, so this is going, okay, so you're doing a random number, and then it's generating point 3 for you. Point 3 is equal to this, and then you're outputting it. Point 4 is equal to that, and then you're outputting point 5 is equal to this. Doesn't stay within range. Well, let's see what happens. Let's see if I do it my way. Okay, so now last part. I want to generate a list or a vector, right? Like we do in C++, right? So how do we do vector? If I just do the term vector, is it the same as in C++, right? So if I said vector of type, and my vector of type is going to be a vector 2D. I can do that, vector of 2D. And it says Alt-Enter to fix this problem. So Alt-Enter. So it's going to generate the vector class. The vector class is a global array of objects. Like an array, it contains components. You can do add and remove methods. And that's how it works, right? So it's like a list in some ways, right? So, and I want to make this, I want to call this, we'll call this points. A vector 2D of points. Let's instantiate it because it's something that needs to be instantiated. It's equal to a new vector 2D of vector 2Ds, right? So specifically, I want to say this instantiates the vector or the container, the collection container, because that's what I'm making. Right? This is an empty collection right now, an empty container, right? And what I want to do is I want to build my points, right? Build point 1, point 2, point 3, point 4. I want to build those points up, right? So instead of me doing all these points, I want to just have a bunch of them in there. And let's generate 4 points, right? Let's generate 4 points, like 4 points that are of point 0. And how about this? If I do this, is there a initializer syntax that I can use as well? Can I say something like points is equal to some kind of initializer syntax, like, for example, a new vector 2D, right? And a new, can I do that like we normally do, right? New vector 2D and a new vector 2D, some random vector 2Ds, or they're all going to be or I can do, actually, the vector 2D, I can do this. How about this? Vector 2D dot 0, which is what I want. Vector 2D, that works, but not this. So if I said I want a bunch of vector 2D zeros, right, that I want to generate here, let's say if I can do this. Can I do this? So a bunch of vector 2D zeros that I want to allocate to points. Is there a way of doing that, like how I have initializer syntax? You know, can I do that kind of stuff? Is there a way of doing this? Like maybe I can do this ahead of time somehow, instead of me looping through and creating a bunch of points. Right, so let's look at that before we go on, and then we'll stop with this craziness. So Java vector initialization. Let's take a look at that. And it says that I can do this, right? As an example, a list, which is in your array list. It says better to use an array list as it doesn't have the overhead of having synchronized methods. You could just use this, blah, blah. They're just talking about what's better. But how do I do initialization? Well, I need to do some kind of for in loop equivalent for each, right? So I can't do this. What I need to do instead is a for each, right? Which is like a for in, right? So for example, for every vector, we'll call it vector, in our vector 2D, that'll go through each of them. Or I can do just a for loop if I had them, right? So if I had them, I can do that. But I want just a for loop, for I. And we'll say we want 4 vectors, right? 4 vectors. A begin and an end, a begin and an end, right? And then I want to do the distance between them, right, really quickly. So beginning and the end, I want to do less than 4. And we can have a, instead of it being hard-coded, we can say number of points. So again, some kind of integer that is number of points. We'll say that that is equal to 4 by default, so we'll put that in there instead. Number of points. And what we can do is for that loop, we can say that vector points dot add, and we'll say a new vector 2D dot 0. So we're just going to add a new vector. That's what that vector 2D dot 0 does. It makes a new vector and it does all this. We're going to do it for all those points. So now because all those points are 0, 0, 0'd, we don't need to do point 1, point 2, point 3, in fact, at all. We don't need to do this stuff. So let's get rid of all this. So we have a bunch of points. We have 4 points now. 0, 1, 2, and so on. By the way, can I access, before I do that, can I access points like this? Can I say point 0, right, dot, and does it do that? Can I do point 0? Because if I can't do this, right, point 0, point 2, and if you notice, if I hover over, right, it says array type expected found Java 2D. How about, can I do points, is there a to list or to array? To array, right, and then can I do 0? Well, yes. And then you can see get class and blah, blah, but that doesn't really do what I want. I want to be able to get, you know, because I don't know what kind of points is when I do this kind of stuff. So what they talked about online when we do a vector is, yes, you can store them, but accessing them, you have to go through some kind of iterator, all right? All right, so this is good, but not good. What about if I made it an array list instead? So if I said an array list of vector 2D objects, what's the difference between an array list and a vector? So again, Alt Enter. We add an array list. Okay, now can I do this? Can I do points 0, right, dot? No, right? Array list also doesn't do it. How about a regular list? Can I do a list? Is there such a thing? Alt Enter. A new list, right? Can I access a new list? And it says, look, a new list of points does not compute. It says, don't know what that means. A new list of points list is abstract and can't be instantiated because that's how it is. So how, oh how, do I make a collection of points? How do I do that? What did you guys come up with? Because you had to do something like this when it comes to your the things that you did earlier last week, kind of. I can't do this, so if I go back, let's just put that back where it was. Here's array list. Array list of points, and I want to get access to a points. I want to get access to the points. So points size, I can do clone contains, but I want to access my point. How do I access each point in my thing? Do I have to convert it to a list or an array? So I can't. Can I do this? Can I access point 0? Like, what does it do for me? What does an array list or even a vector do? It says array type expected found this, a list. Replace with list class, list access, right? Okay, all right, get 0. So get 0 dot, and then I can do get X and gets Y. So that's what it does. Okay, so I can do it that way. All right, let's undo that change. Undo, 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 undo. Let's go back to vector. Okay, I'm just trying some stuff out for you so you can see this stuff too, because you're not used to it, right? So let's say we can't do this, but what else can I do? Can I do get? And I want to get 0, and I want to say from there, I want to get Y and set Y and all that stuff. So that's all it is. Think about get, going back to what I just said, think about get as the portal to access in the class. All right. So I want to get points and so on. So this is what this syntax is what it's going to be, which means we have to modify this stuff. Let's make it work the way it is right now without adding additional load. So instead of point1.set, we would say that we want points.get1.set, right? That's what it would look like. Points.get1, so the first one, or get, in this case, 0, because we want to have the first point. We only have 4 points. So points get 0 is point 1. Undo. This part. All right, so let's put that in there. ToString. Point 2, we don't have to instantiate anymore because we don't have to. We've already got them instantiated. So point 2 will be the same thing. We'll say point 2 is 1, like that. Point 2 is 1. Hopefully you follow me here. Okay, and now point 2 and point 1, right, for the instance. All I want to do is this, right, from 0 to 1. Right? We don't have to instantiate new points anymore. We're just using point 0 and point 1 from the points vector. From the points vector. Okay, so we made a points vector, collection container, and then we're good to go. All right, so we're not going to update now. Let's try it and see if it messes up, if it craps out. All right, so 3, let's go from, 10 to 30, 30. And what do I get? It's in range. Cool. So we got our points, right? And it works just like it did before. Fantastic. Now, here's something that we want to get to before we stop for the day. All right, and then we'll stop for the day. I want to loop through, right? So this builds a vector of 4 points. That's what this thing does, right? Here we loop through and get next line, next line, next line. You enter the first point and the second point, but we want to do this whole process twice, right? So I want to loop through this whole thing twice. So I want to do a for loop, right? Now, we got to think about this. When we do a for loop, every single time values is going to be rejigged. I'm going to have this new thing. I'm also going to do 0s and 1s, right? That's going to happen twice, right, for the for loop. Where when I go 1, I want to be able to use my point 0 and point 1. And then when I go to my second loop around, it's going to go from 2 to 3, right? Because I got 0, 1, 2, 3. 0, 1, 2, 3. Okay? So this number is going to change every single time. So let's try that out. So I'm going to for loop. Here's my for I. And I want to loop through twice. This time we will hard code it. So it's going to loop through twice. Where I starts at 0. Okay, so I want to grab all this. And we're just going to put it inside here, right? So I'm going to prompt it twice. And what I want to do after I prompt it twice is this I want to replace with I. So this is going to replace with I. Okay. Values is just a string, so that's all valid. That's going to be rejigged because values is going to be remade every single loop. Every time we loop through, this will be I. Right? And this will be I plus 1. I plus 1. Okay. And so we loop through. We get to I plus 1. And this will be I plus 1. I plus 1. Right? And this will be I and I plus 1. Okay, problem. I go to the next loop. I'm going to reuse the point. I want to skip. I want to go so that it goes from point 0, right, as an example. It goes from 0, and the next point is going to start off at 2. Right? 0 and 2. Not 0 and 1. Right? So, because remember, it's only going to go through twice. So, the next one is going to be 0. First one's 0, then the next one's 1. 1 is no good. Right? So, what can I do here? Can I make something in my for loop? Is there a step? And I know we're running overtime, guys. Bear with me while we do this. Is there a step that I can move forward in my for loop? Is there an option here for my for loop? So let's look at the for loop. All right, so if I go to the for loop, so I'll say Java for loop step 2. Right, so is it how to make for loops Java increase by increments other than 1, right? Well, you can say you can do plus equal to 3 instead of plus plus. That is definitely a way to do it. And then we would make our for loop bigger. So instead of our for loop being only up to 2, we would want to make it up to 4 or it'll go from 0 and then it'll jump to 2 right away, right? And then when as long as it's less than 3, we're good to go. So in other words, our for loop here starts at 0. Instead of I plus plus, we go I plus equals to 2, right? So it goes 0, then it goes 2, right? 2 would mean this would be, and then when the next loop comes through, 2 plus 1 is 3. So 2 and 3, 0 and 1, right? And then as long as this is less than 3, right? Because I add 2 to it, 0 and 2, that's okay. But when I go to, as long as it's less than 3, it'll loop. It'll try this over and over again. Okay? So this will be the way we do it, right? Just like normal. Let me just shut that down so you can see it. And let's see if we can do this twice. Let's see if it'll actually do it twice. And we'll get 2 values at the bottom. One for my random vector for the first one and the second one. Okay, let's try this again. So again, see if it does it. So the first time around, so let's say we'll say 10 and 20 and 50 and 100, right? Here's my random vector, and what happened? How come I can't do the next one? What's going on? What did I do wrong? Well, I prompted for a next line, yeah? My prompt is equal to keyboard, not next line. That's what it does. So this is nice, but I only want to do this once. So I'm going to take this out and put it over here. Right? And let's try that again. Let's see if that's the problem. So again, I want to say that this is 10 and 20, and this is 30 and 40, and then we got an issue, right? It did it, but it says index 2 is out of bounds for length 2. What happened? Why is it giving me this problem? Array index out of bounds. Well, it kind of did what I told it to do, yeah? Right? It kind of did exactly what I told it to do. So it starts at 0, and then the next one, it adds 2, so it went to 2. So then it says 2 dot set. So 0, 1, 2. I only have 3, right? 0, 1, 2, 2, and then values I. Well, that's a mistake. Values I. That should be value 0. That's the problem. So that was a mistake. I was actually an error in my code. I subbed in I in there by accident. Values are the array values, right? That's just me because my naming convention. Points is what I wanted to increase. So that was my error. Let's try that again. So again, we'll do it again, 5, 10, and then 20, 30. And then it's going to ask me again. This is the first point, right? Enter the first point. And then let's enter the second point. Well, whoa, what happened here? 20, 30 again, and 40, 50. And then we have a random vector, right? Whoa, I only entered it once, but it prompted me to enter twice. Let's get that prompt in there again, right? Because that was the error that was facing before. So let's try it again. One more time. All right, let's try this out. So we'll say 5 and 10, 20 and 30. And now it doesn't allow me to do it again. I can't loop through again with my stuff. This is wrong. That was correct. But when I loop through again, it's trying to get my information again, right? So I was able to do this. So once I do it one time, keyboard.nextLine, I prompt, right? And then I come down here and it's prompting me for my next line. It splits it, right? It comes back my values. It comes back here around, loops back around. It goes, okay, I want to parse this thing again, right? But it skips all this. It skips all this. So what is the solution, guys? Is there a solution? As opposed to me telling you? Come on. So again, let's run through this the same way. So look what's happening. So here's the error I'm getting. Again, I'm here and I'm saying 5, 10, and then 20, 30, and it accepts it twice. It accepted 20, 30 for the first point, for the second point, and for the first point of the next round. 20, 30. So I actually went through here. It went down here, down at the bottom. Random vector is, right? It did this part. It outputted stuff. And then on the way back up, it came back here and it said, okay, I want to get some kind of input right here for my next line, right? And when I did this, when I did keyboard.nextLine, right, it was listening for, it kind of skipped. It kind of skipped over what I had already gotten because I put it in here, right? So what happened? How did I get from here, where I entered my values, my second set of values, I entered it, and then it went up and entered it again? How come? So a couple things we can try. Remember that keyboard also has some other stuff. Keyboard dot. And we can also do a keyboard reset. We tried that before in the past. Let's see what it does when we come back up. And if it does what I want it to do. Stop. Try. So again, 5, 10, 30, 40. There we go. And then the next round is, so this is the first point, first random point. Second random point is negative 10, 20. And then didn't take in the first point, right? So it says it kind of did the same thing, right? Didn't it? It skipped for the first one, and it kind of we did it. It didn't flush my keyboard at all, right? I want to be able to flush my input somehow. We kind of ran into this problem before, so I know I'm running over, guys. So what is the other way to do it? So I want to be able to flush or something like that. We want it to do that. If I did a next line here. So if I said something like next line, if I did a next line here and to ignore stuff, if I did this to ignore, right? So prompt is what I'm doing it. So if I want to ignore this, so next line, let's see if that works. So again, we're running up around the same thing again. So 5, 10, and then we'll say 10, 20. And it's looking for our next line, and now it's going right to the second point again. Doesn't the prompt for the first point should be in the loop? Okay. This part you're talking about. Yeah, but that's what I'm trying to tell you. If I put this part, prompt for the point, if I point that part here, All right, let me show you what happens here. If I take this part out and put it back inside this, here's my prompt for the first point, right? And let's do this extra point down here, okay? Or let's not do that for now. Let's do a keyboard reset, actually. Okay. If I was to do this, when I run through it the first time, I get 3, let's say 5, 10, and then 20, 30. Then it waits for my input, and I get this. Number, format, exception, empty string. Right? I get an empty string up here now. That's what my prompt does for me. When I do this, right, as an example, you're thinking about this whole thing should be in there, right? This whole thing should be in here, is what you're thinking. And that's the mistake that I made. All right, let's try that again. I'm glad you're catching it, because I didn't. 5, 10, 20, 30. Whew. Minus 10, minus 10, 30, 40. Okay. Good. Now that I've got that, what I want, thank you for that. Now what I want that is to take the first point and the second point. I've got those 2 points, right? And I want to generate magnitude from them. So I got 2 points now, random vector 2D, but I'm going to get this random vector 2D twice, right? I don't want this vector 2D to be done twice, to be overwritten. I want to add it to my points, right? So instead of number of points being 4, right, as an example, I want number of points to be 6. I want to add 6 points. 4 points that I'm going to use to get from the user, 2 points that I'm going to generate myself. All right, so I generate all these random points, right? Actually, it really doesn't matter if I do it this way and then down here I add, but I would do this instead. I would say instead of me making a random vector 2D, we'll just say that points dot add this random vector 2D, right? Okay, so that's what I'm doing. I'm adding it to the points value. So now I'm getting 3, 4, right? And what this is going to be is if it's 0, 1, how do I print this out, my random vector? How do I print out my random vector if it's whatever this is? Well, here's a couple of ways to do that. Let's go back to where I was. So you could do this, and then what you can do is add that random vector in. So you can say something like points.add and then random vector 2D. All right, so whatever that is gets added to the points at the end. Okay, so you could do that. And then once I've done this twice, then I have points 0, 1, 2, 3, 4, 5. Right? So this would be points get 4, and then points get 5, right? And then points get 4 to 0.5, right? Get 4, points get 5, and that will do what we want. So from the first random point to the second random point, right? The first random point and the magnitude of the second random point, right, is this, if that makes sense. Phew, let's try that again. So again, we're going to say 5, 10, 20, 30. So that's the first random point, 5.644 and 30. Wow. Did that go outside of bounds? That was what Nick was saying. That went right outside of bounds. So it's 31. So that means that my random vector, when I go to min-max, it should probably be -1. So whatever that is, -1 when I do my random vector. Minus plus min x -1 or something like that, right? Because it adds it on top of everything else. If I go maximum, then I've gone to everywhere plus this. So we could also say max -1 plus min x which is what we want. So max minus 1, right? Plus we're adding a min, but that would not, would that do it? Min x? No. Went up to max. Yeah, minus min x plus min x. That's what it would have to be. Minus min x. Sorry, this is an incorrect thing. So minus min y, because you have to subtract it because I'm adding it on max. Well, I'm adding it on at the end, right? So yes. Sorry, so that didn't work actually. Let me try this. That was what Nick was saying. All right, let's try that again and run it one more time. And we'll do it like this. So 5, 10, 20, 30. That's okay. Wait. What? No. That's incorrect still. Anyway, I'll fix the correctness of this in a second, because that was wrong. It was better. It was closer this other time I did it. Let's try that again. So 5, 10, 20, 30. Yeah, so this is the problem. It's outside of bounds. All right, and then we'll do the next one, which is, let's do it. We'll fix the min-maximum thing in a second. Let's say 30, 50, and 60, 100. All right, so now we can say that the 30, 50, it's just outside of bounds. 60, 100 is inbounds. And then we have the random to the first random point, the to the second random point. And then the distance between the first random point and the second random point is some value, 77.975. So it all works. The only thing we have to fix is this, is this thing, what it generates. So again, this goes from 0 to 1. Let's figure this out for a second, then we'll stop for the day. 0 to 1 times max. So let's say, for example, I put 5 and 10 as the max. So let's say the minimum, so x is 5, 10, and then 20, 30. Okay, we'll use those values. So if I do the minimum value between 5 and 20 is 5. So min x is 5, right? And if I go 20, 30, right? 10 and 30 are the values. The minimum value of y is 10. So 10, right? So 5, 10, 20, 30, right, as an example. And so if I was going to write these values down, so sample values 5, 10, and 20, 30, right? So min x then would be equal to 5, right? Max x would be equal to 20. Min y would be equal to 10. And max y would be equal to 30. Does that make sense? I'm taking this one, and this one, this one, this one, right? So then when I generate values, if I take min x, right? So max x, which is 20, right? So 0 to 20. That's what it's going to do. Plus 5, that means I can get up to 25, which is outside my bounds, right? So it's this, right? Up to 25. So what I want to do is I want to say, I want to generate it from 0 to max x minus min x, max x minus min x, right? Plus min x at the time, right? So that'll give me an upper range, and then I'll add the lower range. That'll be my lower bounds. So I'll do the same thing here. That's what it should be. So max y minus min y plus min y. So this multiplies between this, and this will do it. Sorry, that was my troubleshooting. Just wasn't thinking properly. Okay, let's try that again and see if that works. Sorry, I know I'm running overtime, guys, but I'm just It's the example. It'll be recorded for you. So 10, 20, and then 30, 40. What is that number? So between 10 and 30 for the first number. We're inbound. All right? And between 20 and 40 for the second number. We're inbound. It's low, but it's there. All right, second point is 40, 50. And we'll say 80, 120. All right, so the second one is between 40 and 80. That's good. And then 50 and 120. Low, but it's good. And now we have a value, right? So now we're going, so the first point, as an example, is, so the first random value, which is here, is 12 and 20. 12 and 20. Let's see if this makes sense. And there's the magnitude. And we can subtract magnitudes. If you subtract magnitudes, you can actually get this value, right? That's how you can check. So does that make sense? 94. Sorry, should be about right. 94 minus 23. Yeah, because of the floating point error. Yeah, it makes sense. All right, very good. So let's put this up on GitHub. Now, GitHub, final steps. I've saved everything. I can do it here and with VCS here built into IntelliJ, or I can go out here and then add the stuff that I've changed. So now, let's view changes. Here are all the changes. I want to say stage all changes here. And I want to say something like added Singleton. We'll say Singleton example, actually. Commit to change to 4 files. And then we'll say, once we've done that, we're going to push it to the remote, right? If you do a fetch, you can see now that the remote is behind my local files. My Singleton example's here, but my remote is stuck here. Then I just have to push. And now you're going to see that those two, if I did everything correctly, is going to come together. So now my remote and my local machine are all synced up again. All right, so again, going back to this, if I refresh, you can see simply that I've got 5 commits and we're all good to go. All right, for the people that are stuck around, thank you so much for sticking around. I appreciate it. I know we're way over time, 12:08. Any questions about the stuff that we've done today? And would you do things differently? Is my question to you before we go. The answer is always more than one way of doing things, right? So, all right. If there's no questions, then I'm going to stop recording, and I'll see you guys next week. Just as a recap of what's happening for next week, right? Next week, if you look at it as an example, we're looking at Java packages and access control. Today, I talked about a couple of things, how to use classes, and I've included a PowerPoint here on inheritance. This is for your reading pleasure, so you can see, you know, kind of how inheritance works. It works exactly how we know it works in C++ for the most part. Okay, for the most part, with minor nuances. So please take a read. It won't take long. It'll maybe take you a few minutes to read through these examples. But more or less, inheritance, how we see it here in Java, is pretty much the same. Many aspects that we see in C++, with minor issues. Or C#. If you compare it actually to C#, it's closer to C#, much closer. All right, that's it for me, guys. So next week, just to recap, we're look for an in-class exercise 11 and another Java assignment number 3. All right. Otherwise, that's it for me. I'm going to stop recording, and we'll see you guys next week. All right, I'm not recording anymore. Any questions?